Hello, this is Math 10150 Lesson 4, the first lecture on solving quadratic equations. In this lecture, we will be solving quadratic equations. First, it's important to recognize what is a quadratic equation. A quadratic equation in its most general form looks like this: ax squared plus bx plus c equals 0. There is a term that's a square term. There's a square term. There's a term in which the power of x is 2. And in order for this to be a quadratic equation, the first variable a needs to be not 0. If it is 0, then it turns into a linear equation. So this is a quadratic equation, and there are several different ways of solving quadratic equations. So the first way, if possible, is by factoring the quadratic equation. The second way is using the square root property. And only very special equations you're able to solve using the square root property. And if you're not able to solve the equation using the square root property, you can put it into the form in which you can use the square root property, and that process is called completing the square. And finally, another surefire way to solve a quadratic equation is with the famous quadratic formula. The quadratic formula, if a, b, and c are as above, produces the solutions, which are minus b plus or minus square root of b squared minus 4ac divided by 2a. And last time, when we were simplifying radical expressions with and without complex numbers, we're going to need to use that here again because the quadratic formula has a radical sign in it. And in this course, we're mostly going to be focusing on algebraic solutions to quadratic equations, but it is still important to have in mind that for a quadratic equation, there can be 3 types of solutions. 3 types of things can happen when you're solving a quadratic equation. First scenario is that what's under the square root sign, which is called the discriminant, is positive. If something's under the square root is positive, this means it's a real number. And so the quadratic equation has two distinct real solutions. Distinct real solutions. And while we will not be graphing parabolas in this class, we will be doing that extensively in pre-calculus and calculus. A graph that will correspond to a quadratic equation that has this type of solution will look something like this, where the parabola of the quadratic equation intersects the real line in 2 points. The second type of solution that can happen to a quadratic equation is when b squared minus 4ac actually equals 0. If you look back to the quadratic formula, this means we have minus b plus minus 0, which leads us to only one distinct solution and not 2 distinct solutions. So in this case, there is one distinct real solution. If we were to graph a parabola that has this property, it would look like this. It would just barely touch the x-axis at that one real solution, and we will not touch the x-axis at any other point. The third type of solution that can happen in a quadratic equation is when what's under the square root sign, when that is negative. When that is negative, the square root of a negative number gives us complex numbers. So in that case, we have two distinct complex solutions which are conjugates, which are complex conjugates. So before we start solving these quadratic equations, it's important to know, well, what type of solutions can we get? When we were solving linear equations, the only solutions that we could get was just one number, one value of x for which the linear equation is true. When we are solving quadratic equations, there are three different things that can happen. In the first case, the discriminant b squared minus 4ac is positive, and so we have two distinct real solutions. There are two values of x, real values of x, which will make this equation true. Second case is if we have b squared minus 4ac equals 0, that is one distinct real solution, sometimes called a repeated solution. That is when the parabola just barely touches the x-axis. And the third case is when the discriminant is negative, what's under the square root sign is negative, giving us complex solutions, which are complex conjugates. And the graph for such a quadratic equation will not touch the x-axis at all. So now, in this video, I will do methods 1 and 2 of solving quadratic equations, that is by factoring or by using the square root property. And in the next video, I will solve quadratic equations by completing the square and the quadratic formula. So this I will do in this video, video 1, and these methods I will do in video 2. Okay, so let's do a first example. Let's say we need to solve the quadratic equation x squared minus 3x plus 4 equals 0. You should always attempt to do factoring when you see a quadratic equation. However, if you do not see the factoring right away, then maybe this quadratic equation cannot be solved by factoring, and so you can use one of the surefire methods to solve quadratic equations, which is completing the square quadratic formula. In this instance, either by trial and error or through experience in factoring, I can factor this quadratic equation into x minus 4 and x plus 1. And when you factor an equation, you factor a quadratic expression or any polynomial expression, you're always extracting more information from it. If your equation is already in factored form and you need to solve it, do not multiply things out because you're losing information. And so the main principle behind factoring is the zero product property. And that is, if a times b equals 0, then either a equals 0 or b equals 0. So this is called by several different names, but this is the principle that will allow us to solve a quadratic equation. We're essentially breaking it up into simpler pieces. So the way this equation can be 0 is either the first factor equals 0 or the second factor equals 0. So instead of one quadratic equation, by factoring, we got two linear equations. So this gets us the solution x equals 4. This gets us the solution x equals -1. So the final solution set, and I can write it as a set with curly brackets, is -1, 4. You're always free to check the solution by plugging it back into the original equation and verifying that it indeed works. Another example, this is a little bit harder to factor, but nevertheless, this one can be solved by factoring. Again, if you don't see the factoring solution right away, don't spend too much time on it and proceed to another method that will surely get you the answer. In this instance, I can still factor it. You can do it by trial and error, by the bridge method, whatever you prefer. If I have a 2x and an x here, by the trial and error method or whatever method you prefer, I can see that this is going to be 2x plus 1, and this is going to be x minus 5. And I can cross multiply to check. If I cross multiply, I get 2x times -5, that's -10x, and 1 times x, that's x. So x plus -10x is -9x, and the product of +1 times -5 is indeed -5. So again, I get two linear equations. I get 2x plus 1 equals 0, or x minus 5 equals 0. I have broken up a quadratic equation into two linear equations, and this piece, 2x plus 1 equals 0, is 2x equals -1, which is x equals to -1/2. The second piece, x minus 5 equals 0, gives me the solution x equals 5. So I have two distinct real solutions, -1 and 5. And this is the final answer to my problem. You can also list the solutions without the brackets if you wish. The next example we will solve by using the square root property. Again, the square root property is as follows. The square root property says that if you have something, a variable squared equals a number, then the solutions are x equals plus or minus radical k. This is the square root property. You're just taking the square root of both sides, and then you put a plus or a minus sign in front of it because there's two possibilities that will be squared to make k. And so in this example, we have x squared minus 48 equals 0. It is not yet of the form something squared equals k, but we can easily make it that form by just adding 48 to both sides. And now we need to solve the quadratic equation, x squared equals 48. So by the square root property, x must equal to plus minus radical 48. Now, these are two solutions, plus radical 48 and minus radical 48. However, radical 48 is not in its most simplified term, so we can simplify our answer further by using the product property of radicals. And this is going to be plus or minus 4 radical 3. So the final solution to this quadratic equation is 4 times radical 3 and -4 times radical 3. And this is the final answer. In another example where we can use the square root property, is this one, 3x squared plus 108 equals 0. It's not yet of the form something squared equals k or equals something, but I can put it in that form. If I manipulate 3x squared equals to negative 108, then I can divide both sides by 3, and I get x squared equals negative 36. And now I take the square root of both sides. This is going to be plus or minus negative 36. Now whenever we have a negative in the radical, that means our solutions are going to be complex numbers. And indeed, this is going to be radical negative 1 times radical 36, which is going to be plus or minus I times 6. So x is plus or minus 6i. 6i is a little bit more conventional to write than I times 6. And so the solutions are going to be 6i and minus 6i, two complex solutions. For our last example, a slightly more complicated one where we can still use the square root property, is as follows, and this will lead us to the next method of solving quadratic equations in the next video of completing the square. So let's say we have an equation that looks like this. We have x minus 1/3 in parentheses squared equals 5/9. And remember, the square root property, I'll write it with different letters, is that if something squared equals to k, that means u is plus or minus radical k. Remember, this is the square root property. In this case, what's squared is not just a variable, it's a binomial that's squared, but I can still take square roots of both sides according to the square root property. So if I take square root of both sides, I will have x minus 1/3 equals plus minus square root of 5/9. And then I can add that 1/3 to both sides, and I get x equals 1/3 plus or minus radical 5/9. I can simplify that a bit. That radical, this is x equals 1/3 plus or minus radical 5/radical 9. So x equals 1/3 plus or minus radical 5/3. And so I have my two solutions, 1/3 plus radical 5/3 and 1/3 minus radical 5/3. I can also record my solution set as 1 plus radical 5/3 and 1 minus radical 5/3. Either of these is fine. I can either record my solution like this, or I can record my solution like this. In the next video, we will solve quadratic equations by completing the square and by the quadratic formula.